I've had a few of you say that you're struggling with understanding the work today, so I'm going to talk you through it. The first thing that you need to do is answer questions A and B. So A is asking about the unit for power, so what power is measured in, and the unit of energy that electricity companies use. So we talked about how last lesson about how energy is usually measured in joules, but electricity companies use a different unit, and that is down here. If you have a look, it tells you all about that. And up at the top of the page here, it tells you what power is measured in as well. And then the next thing that you are asked to do is question 1 of the summary questions. So don't do questions 2 or 3, just question 1, and it's filling in the blank. So the first bit is asking about units again, so units for energy and units for power. So you can go back to these and use the same answer there. And then it says power is the energy transferred per, and it gives you that information in the definition of power up here. And you pay, so if we're paying, we're talking about cost. It's about the number of watts that are transferred to your house by electricity. So our cost here is worked out by the amount of power times by the amount of time, and then times by the price. So if you reduce any of these, you would end up with smaller electricity bills. So if you use an electricity company that has a smaller price for its energy, you would have smaller bills. If you used appliances for less time, that would reduce your bill. So if you have a light bulb and you turn it off when you're out of the room instead of leaving it on for 3 or 4 hours while you're out of the room, you'll save money. Or if you use appliances with a lower wattage or lower power, that will also reduce it. So using a 40 watt light bulb instead of a 60 watt light bulb will reduce your energy bills. Then on the worksheet, there were some questions, some calculations. I'm going to go through an example of one similar to question 3 and one similar to question 4. So in question 3, it gives you a power of a bulb. So in my example, I'm using a 20 watt bulb, and it's being used for 2 minutes, and it wants to know how much energy it is using. So they give you this equation, and the first thing you need to do is to substitute power and time for the numbers you have in the question. So it tells you, so you need the power in watts, and it tells you here 20 watts, so you would write down 20 by the power, and here it's asking for the time in seconds, and that's the first place where it gets a little bit tricky because it gives you the time in minutes, not in seconds. So you have to work out how many seconds are in 2 minutes, and you have 60 seconds in 1 minute, so in 2 minutes you'll have 2 times 60. So 2 minutes is 120 seconds. And so now under time, you'd write 120. At that point, I would recommend using your calculator, unless you are particularly good at mental maths, but it's always good to use a calculator just in case to avoid silly mistakes. And that gives you an answer of 2,400 watts. So for question 3 on the sheet, follow the exact same thing. Make sure you convert the minutes into seconds by timesing by 60, and then write down the value they give you for power, the number they give you that you've just worked out for time, and then you times them together, and it gives you your answer, not in watts, sorry, it gives you in joules. Question 4 is similar, however, it's asking you to work out power instead of energy. So, for example, I'll go through the first one of those for you. So the first one says calculate the power of a kettle that uses 100 joules in 20 seconds. So first thing, I'm going to write power equals my energy in joules, and I have energy in joules here, so I'd write 100 divided by time in seconds, and this one gives me time in seconds, so it's slightly easier. I have to put the 20 there, and then again I use my calculator and go 100 divided by 20 gives me 5 watts. Remember, power is measured in watts. And it's the exact same thing you need to do for part B and part C. But with part C, it's a little bit tricky because it gives you your time in minutes instead of seconds. You have to convert that into seconds before you do your calculation. Now, question 5 is about the trickiest question there is here. And it asks you to work out the cost of a filament lamp with a 60-watt bulb and a CFL lamp with a 15-watt bulb for 15 hours. The first thing, I'm going to write down the equation. So cost equals power in kilowatts. So that's a bit different. Before we had been measuring it in watts, now we're measuring it in kilowatts. This is just for when you are using really, really big numbers. It gets easier to use kilowatts instead of watts. Just like how if you're measuring really far distances, you'd use kilometers instead of meters to avoid really big numbers. You do the same thing with watts, times by the time in hours, times by the price, which is per kilowatt hour. So it tells us that the power of the lamp, the first one, is a 60-watt bulb. Our power is 60 watts, but I need to convert that into kilowatts. And to go from watts to kilowatts, you divide by 1,000. So again, use your calculator if you want to. 60 divided by 1,000 is 0.06 times by the time in hours, which was 15, then times by the price, which was 10p per kilowatt hour. Then you go, so you do 0.06 times 15 times 10, which gives you 9 pence. Now you can do the exact same thing for the other bulb, the one that had a 15-watt bulb, and it will give you a different price, and you'll be able to compare whether the 60-watt bulb or the 15-watt bulb are more expensive to run.